Well, good morning. How's everybody doing? My name is Kevin Myers. I'm a network architect for IP ArchiTechs. This is probably about our fourth MUM we've done so far, and we were fortunate enough to have an opportunity to exhibit over in Europe. So this is actually my second MUM presentation of the year, which is kind of nice because it's hard to wait a whole year to roll around for MUMs. So for this one, I decided to do something a little bit different than I'd done earlier in the year. I did actually a lot with BGP in Europe, so I actually ended up changing to MPLS for WISPs, simply because we get a lot of requests for WISPs to want to do MPLS. Some WISPs that don't do MPLS kind of want to know about it. They want to know, how do I get it in? How do I deal with it? Or maybe you have it in and it's not working quite right. So that's why we decided to do a presentation like this that kind of covers MPLS with a little bit of a WISP focus. But a lot of the concepts in here, if you've got a hybrid LAC, if you're a telco, if you're another service provider, most of the things in here are also applicable to wireline networks as well. So let me tell you just a little bit about myself before we get started. I live in Jackson, Mississippi, which is where we have the Jackson office of IP ArchiTechs. We've also got an office in Denver, Colorado. We have an office in Montreal, and we're actually looking at opening an office here in Europe within the next 6 months because we have a lot of work there. So we're really trying to be kind of a global provider for MikroTik for services and consulting. My background is almost all IT in network architecture and engineering. I've spent about 18 years now doing network engineering of various types. Most of the areas that I focus on are service provider, whether it's wireline or WISP, data center, do a lot of enterprise data center and e-commerce, cloud data center build outs and things. And then just networking in general, people that need very specific network projects. Data centers are a really big one now. We get a lot more cloud data center than we ever have because that's something that's really, and white box networking is something we've been doing a lot with. And certifications, we've gone through a whole number of MikroTik certifications, and I'm really excited because they're actually adding some more now. We've got the IPv6 certification that should be coming out, and we've asked them about some others that they're considering, so hopefully we'll see more MikroTik certifications in the future that we can look forward to working on. And before I get in the presentation, I want to tell you just a little bit about my company, IP ArchiTechs. We are the #1 ranked MikroTik consulting firm in North America and one of the top consulting firms in the world. We do a lot. I think the only continent we haven't hit is Antarctica. So if anybody knows somebody in Antarctica, we'd love to knock off all 7 continents and do something there. We're the most successful MikroTik global integrator. We bill thousands of hours in MikroTik engineering across 6 continents and our 3 offices in North America. We were the first consulting firm to offer 24/7 MikroTik technical assistance. So a lot of you guys come by and like, why do you have a Tic Tac outside your booth? And I told this story in Europe, and there was like a line outside our booth afterwards. But the story goes, we came from a Cisco world, and so when we entered the MikroTik world, we kind of wanted to offer 24/7 support to the MikroTik world like a Cisco TAC. So we were like, oh, well, why don't we build a MikroTik TAC? And we were like, oh, it kind of sounds like Tic Tac. So that's kind of where the whole Tic Tac thing came from. And so it's just kind of a little thing that we do, but that's a service that we offer, and it's been very popular because a lot of people need a critical resource that can help them out and bail them out when they have issues that's 24/7 and can cross all the time zones of the globe. So that's something we've been very successful with. And certainly at scale, everybody operates at a different scale. Some people operate at a small, medium scale. Some people operate at a large scale. And one of the things that we do is we've been fortunate enough to work in some really large networks, some large publicly traded companies, and some really large environments. So one of the things that we try to do is a lot of the lessons you learn in networking are the same, whether you're working in a really large network or a really small network. So we try to take some of the lessons we've learned in networks that have tens of thousands of routers and switches and apply those to networks that have just a small number of devices, because we find that a lot of the lessons we learn tend to cross over and develop best practices for small and medium networks as well. So our services we offer are global professional services, consulting all over the world, fully managed network services. So if you want just a chassis or something managed and completely monitored and managed around the clock, we do that. And we also have 24/7 support contracts by chassis. So you can put a couple CCRs in your core on 24/7 TAC support with us and have a 4-hour SLA so that if you need that lifeline to bail yourself out of an outage, you can call us if you've got that support contract. We have support now in 4 languages. We support in English, French, Polish, and Spanish, and we're looking at adding potentially Russian and some other languages to our portfolio so we truly can be a global support provider. So let's talk about MPLS for a little bit. First of all, it's hard to try to distill MPLS down into just a 30-minute presentation or a 45-minute presentation, and so I'm going to do my absolute best not to bore you and try to cover just a little bit about what MPLS is and then get to the parts where how it's relevant for you as a WISP. So in the theory of MPLS started back roughly in the 90s. It was originally designed to solve a performance problem for Cisco. Before Cisco had ASICs and all these things in their routers, and their routers were CPU based, they had a performance problem, and so they thought MPLS could help them solve it. It was called tag switching back then. And what tag switching did was it replaced your standard IP address and your 32-bit address with an MPLS label. And so because they were dealing with less information, the idea at the time was that if you had less information to deal with in the forwarding of your traffic, you could actually make the network go faster. And they actually did have some success with that, and now it's not really why it's used, because a lot of the stuff in different vendors is ASIC based. And in MikroTik, I've never observed it to be any faster. I know I've heard people say it should go faster, in theory it should go faster, but I don't know that I've observed any major CPU reduction as a result of that. So what it really does is it helps you, it gives you the tools to build some really elegant solutions to solve some very complex problems in your network and scale your network out, even if you're a small provider. So we're going to talk a little bit about the theory of MPLS networking. We're going to talk about the design of MPLS networking. We're going to talk about some best practice designs and things that you should be putting into the design of your MPLS network if you don't have it in. And one of the important things that often gets overlooked is we're going to talk about the business justification for it, because a lot of people in here are small business owners and they want to turn a profit. So it's very important to understand, how does this help my business? How does this technology help my bottom line and help earn money and revenue for the business? And we're going to talk a little bit about how MPLS can help you do that. And then the building aspect of it. If you guys want to get into deep dive technical, we can certainly just hit me up at the booth and we'll get into like a real deep dive, but I'm going to kind of show you about 4 different scenarios of how you would deploy MPLS, and reasons you would deploy MPLS, and how that can help you. And then if you want to get into some real deep dive, certainly there'll be time for questions after this, and then we can certainly go out and talk more in depth after the presentation. So here are probably I would say the 3 main things that are the problem we're trying to solve with MPLS as it relates to a small and medium provider. The first one's going to be isolation of traffic. MPLS is probably the gold standard in networking for isolation of traffic. If you have a need to build separate routing tables, if you have a need to privately transport customers through your network but not let them see other parts of your network, or if you have a need to connect to data centers, whatever it is, MPLS is going to be the protocol of choice to build that isolation, because its ability to transport routing tables and exchange routing tables using BGP with MPLS there really isn't anything else like it until you get into the SDN world. So certainly, and if you have to deal with compliance, if any of you have to deal with PCI compliance, HIPAA compliance, some other kind of standard, a lot of the security standards that come out now require logical separation of networks, and so MPLS is a tool that you can put in to do that if you have those requirements around your network. Transporting other protocols over MPLS. MPLS does a great job at this. The one in the MikroTik world we tend to do most frequently is putting Ethernet inside of Ethernet with VPLS. But if you branch out, you can actually put things like ATM into MPLS. You can put T1s into MPLS. So there's, if you have an MPLS backbone of MikroTik, you can attach other devices to it and transport other types of protocols over it if you need to. And that's actually something that's still really popular, because there's still a fair amount of ATM and T1 infrastructure, at least here in the United States. And if you have a need to do away with a legacy circuit and transport that over an IP backbone, then using MPLS makes a lot of sense. And then reducing complexity and increasing flexibility. I can't count the number of times people come to us and say, well, I've got my network and I've got this customer that is going to bring me a lot of revenue, and they want to do this thing where they want me to connect their locations, and they want internet, and they want all these different things, and I have no idea how I'm going to connect those guys together. And so MPLS is almost always the answer to that, because it's like a Swiss Army knife of protocols. It allows you to take these things that you need to isolate and transport through your network and solve all these different problems in a much more elegant way than doing policy routing and just trying to build isolated routing tables inside your network. It kind of glues everything together into a cohesive solution. So let's talk about what it is at a protocol level. Essentially, you're often going to hear MPLS referred to as layer 2.5. People talk about it as a shim header. If you get around a lot of the network geeks and IETF, there's a whole fair argument around what MPLS actually is. But it's probably accurate to call it layer 2.5, because if you look at the frame header in Ethernet, it sits right between layer 2 and layer 3 in the IP packet. You've got your 32 bits that makes up of the label value, which is 20 bits. Your experimental bits, which is your quality of service. So when you get into quality of service with MPLS, you have to map, whether if you're coming out of DSCP, you have to map into the experimental bits. And that's something that, especially in the MikroTik world, which is a little bit different than other network vendors, with MPLS, once you've put something into the MPLS network, actually actioning on it in QoS in the middle of the network, as far as I know in version 6, it's currently not possible, so you would have to have a layer 3 switch or something else to action on QoS in the middle of the network. You have to deal with it at the ingress, at the edge of the network. So that's something that is unique about MPLS in that respect when you put it on MPLS and MikroTik. And then the S bit is the bottom of label stack. So when you get to the last label in the stack, the S bit can be turned on or off. That's why it's there. And then just like an IP packet, it's got a TTL so that you don't have MPLS packets circling the network forever. So one of the things that drives MPLS and makes it work is label distribution protocol. Now, there are ways to distribute labels without label distribution protocol. You can do static labels, which, other than doing it in a lab exercise, you do it in the MTCINE. It's really not practical to do anywhere else. It's useful to kind of understand how it's done, but with the advent of LDP, which is the protocol that acts as the distribution of label protocol, there's really no reason to use anything else, unless you get into traffic engineering, which can exchange labels without LDP. So that's certainly something you can use if you need that. It's kind of like a routing protocol. It's not quite a routing protocol. It kind of acts as the control plane for MPLS, and it allows the label exchange so that MPLS can build its forwarding table. And it relies on an IGP. So in MikroTik, your only real choice is OSPF. I think technically RIP works in MikroTik with MPLS, but I have no idea why you would want to build an MPLS network over RIP. So OSPF tends to be the protocol of choice when you're building an LDP and MPLS network with MikroTik. If you get into integrating MikroTik with other network vendors, you might run into using ISIS or EIGRP, which are also valid IGPs to build an MPLS network. So let's talk about the forwarding a little bit of routing fib versus MPLS fib. So when you get down to the guts of actually getting a packet in and out of a router, you're really in something called the fib, the forwarding information base. And this is pretty common across any router you touch, whether it's Cisco, Juniper, MikroTik. Everybody has a fib that the routing table gets pushed down into, and it's the actual determining of which interface does this go in and this go out based on my routing table. And that's what the fib is. So this is just the routing fib. This isn't the MPLS fib. This is, you have your route cache, the information is drawn from the routing table, and then it gets pushed down in the forwarding information base is where you actually push your traffic out. And I actually asked MikroTik, I don't know that the graphic exists for the MPLS fib. There is an MPLS fib in MikroTik, but I don't know that a graphic exists, so I had to pull a more generic one. So this may not be the exact flow, but it will kind of give you an idea of how this works when you're converting to MPLS. Essentially, you have your IGP up here, which is OSPF, where you learn all of your routes. And I don't know, some of you, if you stop by our table, we have the little world's smallest MPLS network that we've built and set up. That's a great topology to illustrate like how an MPLS network works with OSPF and the role of OSPF. And if that's something that you want to understand better, come by the booth and I can kind of show you where OSPF fits in, where BGP fits in, and where MPLS fits in on a topology that you can kind of touch and look at, because it can be confusing if you've never done MPLS before, what routes go into OSPF, what routes go into BGP, and then how MPLS glues this all together. So OSPF is going to feed information into the IP forwarding table, and then BGP is going to use its routes, which are what we call traffic routes. So traffic routes are anything that are your customers, your hosts, anything that is an end station that you want to route, whether it's a server or a subscriber. OSPF only manages loopbacks and transit subnets, and we'll get into that in just a second. All of that information gets dumped into LDP. LDP takes the connectivity information from OSPF, builds an LDP database, and then builds a label fib. And that's what is eventually, it becomes the forwarding information base of MPLS. Here are the basic components of an MPLS network. This terminology, if you go talk to any provider pretty much in the world, whether you're talking to here in the US like AT&T or Verizon or those guys, everybody uses this terminology to describe their networks. So you have, those are actually P routers in the middle. This graphic is wrong, but the middle router is a P for provider. All it does is label switch traffic. That's its only job. is a high capacity router to take in traffic and label switch traffic. And we have an example of that in those small MPLS demo that we have out there at the booth. Then you have your PE routers, which sit outside of the P network, which are your provider edge routers. These are the routers that are the demarcation of your network. They face your customer. That doesn't mean they physically have to be located where your customer is. It just means from a logical standpoint, they face your customer. And then at the outer edges of the network, you have the CE routers, which is the customer edge router. And that can truly be a router that your customer brings and peers into your network and takes routes from your network, or it can be a router that you provide and you manage. It doesn't matter. A lot of, especially if you have small companies that don't understand networking and routing, that's a business opportunity for you to own that CE router. And even though you may sell it to the business and they may lease it and it may be theirs, but you manage it. And that's a way that you can add value to your company by doing a customer management solution like that, but you still keep it isolated from your provider network. So that's a great opportunity to get some revenue. So provider edge router, we've already talked about this. It's also known as an ingress-egress label switch router. It's a router that is between one service provider area and another area that's administered by other network provider. That's how Wikipedia defines that. It just means that your area of control is your provider network, and the provider edge is where you demarcate between you and the customer. P router is almost always what you would call a core router. It's something that doesn't face or touch the customer at all. It takes in all the PE routers and routes and switches them inside of a core. And then the customer edge router, again, is on the customer prem. And this is typically when you get into VRFs, which we're going to talk about, which is the isolated routing tables that so many people are using MPLS for. It's called routing mark. It's actually called routing mark and VRF inside of MikroTik, so it gets a little bit confusing because you have both terminologies that essentially amount to the same thing. And that's where you would deploy that in your customer edge router if you want to have an isolated VRF inside your network for that customer. Pushing that out to the customer edge network, and the PE network is where you would have that. So let's talk about some of the guts of MPLS. So I put this slide first because in the several years that we've been doing this as consulting network architects for ISPs and for WISPs, this is the single biggest problem that we see when people are trying to deploy MPLS is none of the MTUs are right. And it actually goes beyond just making sure that you've set your MTUs right. It is very important to actually audit using pings and other troubleshooting mechanisms how much MTU a device will actually pass. Especially in the world of point-to-point radios and commercial RF, there's a number of times where we've seen devices of all different manufacturers where you'll send a packet in and it'll be set for jumbo and it may be set for 9,000 and you think I'm all good, it's set. And when you actually audit it with a ping, you find out that it's not actually passing. There's a bug or there's some other issue and it's not actually passing that size of a frame. And that's probably the most common thing we troubleshoot where people say, oh, my MPLS network's crashing and I've got bugs and nothing's working right. I'd say 9 times out of 10 it always distills down to either an MTU is set incorrectly or an MTU is set correctly, but it's actually not honoring the MTU size that needs to go through that transport segment. So before you ever think about putting MPLS in your network, you really kind of need a full audit of all your MTU capabilities. And if you can't meet 1530, which really, if you're going to do MPLS, I've listed what you have for MPLS Basic, which is 1508, which adds what you need to get into MPLS labels. Your L3 MTU being 1500 for a standard non-MPLS layer 3 segment. And then your L2 MTU needs to be 1522. If you're going to do MPLS, there's very little reason to go with the basics because you're going to shortchange yourself with the services that you can deploy, like VPLS. You could do untagged VPLS. Those MTU requirements are 1526 for the layer 2, 1500 for layer 3, and then 1526 for the MPLS MTU. But typically, most people that want to deploy VPLS want to deploy it tagged, and most of the gear that's coming out now can support at least 1530. So the gold standard is really 1530 or higher. If you want to set higher, you can. But typically 1530 is sufficient since a lot of ISPs are trying to transport 1500 byte internet segments. There's usually not as much of a reason to go above 1500 unless you know you're going to have heavy transport privately in your network. So you may have a section of your network that goes jumbo frame and then go back to 1500 at the edge. And it just kind of depends on what your traffic flows look like in your network. So, and MikroTik will put this out. This is the slide that you absolutely have to know by heart. This is the thing that when you put this in, if you don't have it set like this all throughout your network, you're going to have issues. So let's talk about getting your WISP ready to support MPLS. CPU, I can't say enough about making sure that you upgrade your routers, your tower routers, routers that you have in data centers, colos, to keep your CPU as low as possible. The happiest MPLS networks when you're deploying MikroTik gear are networks that see very little CPU usage, as low as you can keep it. So as much budget as you have to bump up your routers, absolutely put it in, because it will pay you back 100 times over by keeping those CPUs low. And this is something that's kind of an important distinction between the way MikroTik does MPLS and the way just about every other network vendor does MPLS. If you get into the world of dealing with like Cisco or Juniper or Brocade, it's all ASIC switched. So you have an application-specific integrated circuit that will send that traffic at wire speed. So the CPU is really only there for the control plane of the network, and it's all ASIC wire speed. In the MikroTik world, we have things like FastPath coming in, so you have some of these things that are intended to optimize the flow of traffic, but it still all has to go through a CPU. So the way you have to think about designing your network for MPLS with MikroTik is just slightly different than the way you would approach it with a different network vendor. So CPU is critical to make sure that you have a very happy network. And then memory. Memory is one of those things where you want to have as much as possible, so that if by some chance you need to dump a full table somewhere, or you need to do something else that's going to require large memory, maybe you want to do some caching or something, it never hurts to bump up the memory if you're going to have to go get a bigger router, because someday you're going to use it. You may not use it right now, but someday you're going to need it, and it's a whole lot easier to have it on tap than it is to go forklift something out of the core of your network or in the distribution of your network and put it back in. And quality of service, we talked a little bit about the experimental field. You've got to really understand the way DSCP translates into the experimental bits if you want to have a properly built QoS network. Now, you can get away with building QoS without dealing with DSCP and the queuing architecture that MikroTik has. But if you want to expand your network and you're going to integrate other vendors into your network, then you absolutely have to have a DSCP QoS mechanism to be able to deal with other network equipment, because that's the gold standard in networking for QoS. And then when you deal with experimental bits, which are different because those are part of the MPLS label, not the IP header, you've got to do a mapping from DSCP to experimental bits. So, and that's a very critical thing to get right so that you have a well-tuned service provider network. The only other thing I'm going to say on QoS is the highest priority of QoS in your network should not be video, it should not be voice, it should not be any of the other real-time protocols. Network management should always be your highest priority in quality of service, because if OSPF can't form an adjacency, if BGP can't peer up, if there's not enough bandwidth for all of your control protocols, then none of your other traffic matters. So network management always gets highest priority in QoS. So MTU, we've kind of beat MTU to death, so I'll leave MTU alone, but certainly the slide will be there for you to review. So using BGP and OSPF to support MPLS. This is an example of the network that we have out there that you can physically go look at. And this is kind of illustrates the differences between BGP and OSPF and the roles that they play. So one of the things we see with a lot of WISPs where they're growing, and everybody kind of starts out the same way. It's an organic thing. You get built on a shoestring budget, and then you get a little more, and you try to add some more capacity. And trying to wrap your head around some of these complex things is tough, like OSPF. So usually we get a lot of OSPF networks that will get up to several thousand subscribers, and then they'll start to have issues because OSPF convergence will continue to start going down and down, and if you add redistribution, you'll see the performance go down even further as you scale into maybe close to 10,000 users and things like that, simply because OSPF, its main job is a topology protocol. It's designed to map the physical topology of a network and understand paths. It's really not designed to load with thousands and thousands of routes. That's what BGP excels at. So the way to have the best of both worlds is to put all of your transit subnets that you have here in green into OSPF, and then your loopbacks as well. Those are actually blue, but they should be in green to put into OSPF. And in some cases, you'll have multiple loopbacks that you will advertise in BGP, but the loopbacks you peer on, those will all be on OSPF, and then only those subnets in the clouds that are in blue that are what we call our traffic subnets, where your subscriber lives. Those are the subnets you hand out. Maybe they're public, maybe they're private. Those are the ones that go into BGP, because those are the ones that are going to scale. Those are all the routes that you're going to have. They're going to get into the thousands. And then putting that in BGP gives you the ability to scale. I mean, the global table's 560,000 routes now, so you have an immense scalability capacity by putting that into BGP. And the other big advantage is you have policy control now. So, I would say, if you've ever built your WISP into a ring, raise your hand. if you have some kind of a ring in your WISP. So most WISPs that we've dealt with have some kind of a ring, and they get to a point where they start messing with OSPF cost to try to get traffic from one way to the other. Once you bring BGP into the picture, you don't have to sit there and mess around with cost as much. You can just write a policy to say, if you're in this subnet, I want you to go this path. And if you're in this subnet, I want you to go this path. And you can kind of start to load balance your traffic. So one of the other tools MPLS brings is traffic engineering. So if you combine MPLS traffic engineering and BGP, you can pretty much dictate any subnet in your network wherever you want it to go. You can make it take any path that you want to and not be bound by the rules of cost and OSPF. So from that aspect, it's great to really use all the available backhauls and point-to-points that you have in your network. So when you do MPLS, do it carefully. Get yourself a lab, get yourself some test equipment, and start playing with it and try to understand what it's about and how you put it in is the first thing that you want to do. When you get ready to the point where you want to put it into your network, pick a low priority segment. I always tell WISPs that the next tower that you've got in line, if you've got a tower that you're not quite ready to put in production, but you've got the stuff, make that your first MPLS segment. Rather than trying to retrofit the whole network, get yourself some MPLS gear that you're ready to the core, and put that next tower onto MPLS. Get it all tested and working before you put the first subscriber on it. And then you'll have an MPLS ready segment to put new customers onto. And once you kind of understand the mechanics of it, you can start to retrofit your other towers. And that's a migration strategy you can use to not have to try to bite off every part of the apple at once. You can kind of do it a piece at a time. And again, back to the CPU thing, don't be afraid to use new hardware. Even to the point, we have a WISP, it's a combination of a WISP hybrid ISP that's fiber up in the Pacific Northwest. And we actually made the decision to put new routers at all the sites rather than convert the existing routers, because converting the existing routers was going to take about 10 times longer. So the cost in time to convert all the existing routers was actually way worse than just buying new routers and putting brand new routers in parallel and doing cuts over to the new path. So don't be afraid to bring some new hardware online and just do a quick cut over rather than trying to reprogram something that's there, because sometimes that can be a faster way to get going. So let's talk about the business case for MPLS. So one of the things that you'll find if you're struggling to compete with the AT&Ts and the Verizons and the Comcasts of the world, especially to your business customers, and you want to offer this out to your business customers, and this is something I did some Googling, just pulled out some average MPLS circuit costs versus a raw internet cost. So if you've got a business that needs a synchronous pipe, let's say they need 5x5, for internet, maybe you charge $200 for that. And this varies all over the country, so this is a general example. If you take that same circuit and sell them an MPLS circuit where you're going to manage routing for them, connect their business together, maybe you do some managed router services, whatever it is, on average, you're going to be charge almost 4 times more for that MPLS circuit because you're providing a premium service. You're going to put quality of service on it. You're going to guarantee that their traffic gets there better than best effort internet. So even if they end up buying internet from you that you put out of the data center, you're still giving them a more premium service, and you can charge more for that. And not everybody is going to want to take that, but there are businesses that are going to see the value in having priority access and want to get into something like this, or they're going to want you to manage the routing for them. And that's a way that you can take the exact same shot that you're going to do to that customer and make more money on that. So, and that's something that we've been doing with a lot of the larger WISPs that we do consulting for, and it's been very popular. They actually are finding that they can compete with the larger carriers by offering some of the same services that the larger tier 1 carriers have. So the other reasons on the business case are lowering the OpEx cost by increasing agility. MPLS gives you the ability to roll out just about anything you can think of if you need some kind of a service at the edge of your network or to cross 2 edges of your network. And you can do it in a fairly templated and repeatable way. You're not having to do all these one-off type configs to try to bring things through the network. You can throw an MPLS endpoint router out on one end of your network and throw an MPLS endpoint out on the other end of the network. And you can do a layer 2 VLAN all the way across if you want to with VPLS. You can do an L3 VPN where you build a VRF through it. You can even provision multiple services off the same router. You may provision a VPLS tunnel for private transit, and then you may provision another VPLS tunnel for BGP peering back up to your head end and become a BGP peering transit provider for an enterprise customer or somebody that needs it. So there's a whole bunch of things you can do, and it's just like the Swiss Army knife that you pull that blade out when you need it, but it's a very organized way of doing it. So it's going to lower your operational costs by not having to do one-off things. Building private customer networks outside your service area. You can actually extend your service area by leveraging a number of different tools. We have a lot of ISPs that are actually extending their service area by either buying internet connections and doing VPNs, or maybe they buy dark fiber or layer 2 transit. And so a lot of times we have customers say, well, I've got this customer and they've got like 5 locations in my service area, but they've got 2 locations that are not my service area, so I can't serve them. I said, well, why not? And they said, well, they're outside my service area. I said, well, go buy transit and sell them a solution. Stop selling circuits and sell them a whole solution. And MPLS allows you to do that. If you buy the transit that you need, and this is what all the tier 1s do, in the enterprises we work with, I'd say there is no tier 1 that we work with for large enterprises that serves 100% of the circuits themselves. I'd say at least 30% of the circuits for the big publicly traded companies are fulfilled by another carrier because they just don't have a last mile everywhere. So they'll just go buy, if it's Verizon providing MPLS, they'll go buy the last mile they need from Level 3 or AT&T or Cogent or whoever owns it, but they'll put their name on it, brand it, manage it, and sell it as their own. And so one of the things we've encouraged a lot of WISPs and smaller ISPs to do is do the very same thing. Sell them a whole solution instead of selling them just the links that you have in your service area, and your revenue is going to go way up. And that way you can think and act and be like a big carrier to your business customers. And then resell your network. You know, there's areas that you reach that nobody else reaches. You know, the game of carriers, when you get into the tier 1s and tier 2s, all they do is resell services to each other in paths and fiber all day long. So don't be afraid to reach out to other carriers and say, if you need transit in my area, I will sell you transit. They may say no, but there's a chance that they could say yes, because if they know that you're willing to sell transit and you have the ability to peer with them in a way that they understand, whether it's an MPLS exchange or something else, then they may say, yeah, I've got this customer I have no other way to get to and we want to sell this service, so we'll pay you that $2,000 a month transit cost. And transporting legacy technologies. We talked about ATM, frame relay, PPP, T1. You may have somebody that has a need to transport a legacy technology, and you may be the only person that's able to do that. But if somebody doesn't know that you have the ability to do those services, if you're not interacting with other carriers and cultivating those relationships, then you're not going to get approached to do those things. So that's a really important part of it as well. So we've got 4 use cases, and I promise we're getting almost to the end here that we're going to go over that kind of illustrate where you want to use MPLS in a WISP. So the first one is PPPoE aggregation with MPLS. If you do PPPoE network, whether you're a DSL shop, whether you're a WISP, if you do PPPoE, then this is a really popular model because PPPoE requires a continuous layer 2 broadcast domain to get all the way back to the BRAS where you're going to terminate your traffic. So this is actually a model that the telco networks came up with a while ago. This was really started to get really popular in the middle 2000s with telcos, where they would use VPLS and MPLS to backhaul VLANs over fiber networks and DSL networks back to like a common CO or data center to aggregate all their PPPoE. And so with a WISP, you can do the very same thing and build VPLS VLAN tunnels back to a common point and then have a BRAS, whether it's maybe a 1036, a 1072. You may spin up a VM and do it in a VM and that kind of software. But you can use layer 2 tunnels to isolate the sections of your network and the regions of your network and bring all that PPPoE traffic back to a common BRAS. So that's something that you can really use, and that model works really well. When I was a telco engineer, before I became a consulting engineer, we had about 25,000 subscribers in a DSL network, and we backhauled about 900 VLANs back to different BRASs. So it's something that can scale a lot. It can go way up there, and it works pretty well. So BGP peering with a full table. Some of you may have come across this yet, some of you may not, but when you get to a size, especially when you get your own AS and your own upstreams, typically when you start to get into several thousand subscribers, a lot of WISPs are going to have customers that say, I've got Cogent upstream, I've got AT&T upstream, but you guys are in my service area and you guys have got wireless, so I'm not dependent on like a physical fiber cut, and I would love to do a peering with you guys over RF so that I've got redundancy in my AS. So can you guys send me a full table? And if you don't have MPLS in your network, you can do it, but it's a lot harder to build that into your infrastructure because you would have to carry likely a full table through your network unless you could do an EOIP tunnel or something like that, but scaling that would get difficult. With VPLS, you don't have to bring a full BGP table through your network. You can only bring the BGP table into your edge routers and then bring it down into, say, a route reflector on a VM that's in your data center that's designed just to serve your customers. and then you can use VPLS to transit that public/30 all the way to the customer. So if it's 10 routers out to the customer, you put an edge router out there as a VPLS endpoint, build your VPLS tunnel back to your core, and then you stretch a public/30 and do a BGP peering with them, and then hand them off a full table, and you've not killed your entire core by trying to bring a full table through it, which is a mistake we see quite often in the WISP world, where there's a thought that you have to bring the full table through the network, and the performance is just it's horrible. It really slows down the network. So you really want to keep those full tables up at your edge routers, and then advertise summaries or maybe some specific routes along with defaults to migrate your traffic around until you get into MPLS traffic engineering. And then private L3 transit. This is what people call the MPLS cloud. So a lot of business, if you hear of like Verizon Business, AT&T Business, Level 3's got this. They will go into an enterprise and say, we've got 200 branches across the United States, and we want them all to go into an MPLS cloud, and we want you guys to manage the routing, and we're just going to connect our routers to this cloud. You can do the very same thing with an L3 VPN in MikroTik by essentially building that private slice of the network through your MPLS network and connect customer site 1 to customer site 2 and use private routing and not have it overlap. And that's a really common deployment scenario. And that's something you can charge a lot of money for. If you have a business that wants that or needs that, that's a service that you really can capture a lot of revenue on. And then private L2 transit. You may have 2 sites that they may want something as simple as they just want to be on the same LAN segment and share printers and services, and it may be a Microsoft network. When you get into some of the heavier stuff, you may want to connect data centers. It's incredibly common for data centers to need layer 2 transit, and so if you know where those are and can be one of those providers to connect data centers together, whether it's a large colo data center, maybe it's an enterprise data center, they're constantly asking for layer 2 transit between data centers, and they can't build enough capacity to serve all the data centers that are being spun up. So that is, and any other layer 2 services that you need to sell between 2 points. That's a huge way to increase your revenue share, is selling those kinds of services. So now I want to go ahead and open up the floor for any specific questions that you may have.
Do we have questions?
Anybody? Questions? Okay.
Everyone.
All right. Well, thank you very much. I appreciate it.
Thank you, Kevin.